I'm going to start by showing you how to build a basic contingency table in JASP. I'm going to do two examples. I'm going to do one on individual data and one on household level data. So to start with, I've just launched JASP and I'm at the home screen and I'm going to open my data. So at this stage, if you've been working with JASP already, you should see your last open data set in this recent files tab. If not, you can browse down here through your computer where it will also display recently opened folders. Or if this is your first time using it in a while, or you're using it for the first time on a new machine, you can click browse here to navigate to your folder. So I'm going to open it from recent files. Now the tab that we're going to work with today is located up here. It's this frequencies one. And you see here there are two versions of this. There's the Bayesian and there's the frequentist. So the one that we want to use is the one on the top, this contingency tables. So I'm going to left click here. And again, as with the other tests and other procedures, this takes us to the results window. And again, if I want to maximize the results viewer, I can use these arrows over here on the sides to redistribute the screen. I can manually drag it over and resize it if I want to. I can display some of the data grid also if I want to. So for the moment, I'm just going to keep it to the actual variables list over here on the left and the results window on the right. So first of all, what we're going to do, before we do this, I'm going to just implement a setting for individuals. And if you remember back to the previous lessons, the filter that we're going to use, we're going to start with individuals. And to do this, we're going to find the variable that identifies individual income. There are several that we could use, but the one that we're going to use is net individual income. So if you look down through here, and again, a useful way to look for these is we'll be using scale variables to select on income. So keep an eye out for variables that have this little logo here. This is the logo for scale level of measurement. And as we scroll down through the list, you'll see here the one that we're looking for is the one that concludes with the INC_I. It's the _I ones that are going to measure income at the individual level. So once we get down here, we've got annual disposable income. We transfer, just click on it to transfer it over to the window here, and then we're going to ask it to return only cases with an income greater than 0. And I'm just typing in those boxes there. Once you've got this entered, you click apply pass-through filter, and now the filter is applied, and we can see here, because there happens to be a case at the top that meets this condition, we've got this case struck out from the list. So once that's done, you can close that and you can go back to the window, and from here we're going to start transferring over variables. I'm going to introduce an important convention in these tables, which is that we're going to place the independent variable in the rows and the dependent variable in the columns. The reason for this is because when we read the table, you'll see we're going to make some additional settings down here in a moment. When we set up the table, we want to make sure that our percentages sum within categories of the independent variable. And it'll become apparent why this is the case as we go through this lesson. So the first thing I'm going to do is I'm going to identify my gender variable, which carries the variable name SE. We'll transfer that over to the rows. Now you see automatically the table is starting to set up for us, but we don't have any results here yet because we need to define an independent variable and a dependent variable. Our dependent variable is going to be employment status. And we're going to use the SOC code measure, which is sort of a crude indicator of social class, this SOC code 2.1. And I'm going to transfer that over to columns. And now you'll see that we have some results starting to appear in the window. If you want to at any point, you can snap this window back and forward to look at the full table. Now it's quite long because you'll see it's retaining all these long form labels, which is not especially helpful for reading it. So if you're copying this, if you were to copy a table like this over into your reports, let's say, you might want to format the page so that the table's on its side, or you might want to manually edit these labels. So this is telling us that within the group of males, 424 were managers, 527 are professionals, 182 females were managers, 830 were professionals. We don't want to leave it at this because we can't infer anything about the relative differences between these two unless we're looking at percentages. So again, this is why we set up the table like this with the independent and the dependent variable in these different places. So what I want to do is go down here to statistics. Now the chi-squared statistic is turned on by default, but we also want to return this one here, phi and Kramer's. We want to make sure that's checked. And then we're going to, what will happen then when you check this is a third table will appear down here, which gives you the Kramer statistic. Now I'm not going to talk about the interpretation of the different figures here. If you're looking for interpretation of these, please do refer back to your class notes particularly the class that we conducted in classes from weeks 5 and 6, and that'll explain how to locate and interpret the p-values. As we go down then, there are 2 further options we can open up and expand, one for cells, and down here in cells we want to click on row. Now what this is going to do is it's going to give us percentages but within rows. And this is important because now this is going to tell us the percentage of males who are managers, the percentage of males who are professionals, the percentage of males that are associate professionals, and so on. And now by reading between these 2, we can see if the percentage of males who are managers differs from the percentage of females who are managers, and we can start to infer if there are any differences here with along gender lines. On the options, we have an option to change the column orders. It's not really necessary. There is an order to these ones, but again, we kind of want to leave it as it is. So let's snap the table over and just take a look. Now, one thing you want to remember in JASP is that when it reports percentages, it reports them in the format of proportions. So when you're reading a proportion, it's quite easy to convert between them, and they're essentially, you can read them pretty much the same. So if we were to say that, say 10% of males are managers, another way to say that using proportions is that 0.1 or 0.10 in this case, the 2 decimal places, but it doesn't really matter. 0.1 of males are managers and administrators, 0.12 of males are professionals, or we could also say 12% of males are professionals. So to do this, you can simply move the decimal over 2 places. You can multiply by 100, whatever way you want. But to convert proportions to percentages is relatively straightforward. This is 10%, this is 4%, this is 12%, this is 18%, and so on. So what we were able to do on the basis of this then is by looking between the 2 rows of the independent variables, again looking at the rows which show the categories of the independent variable, this one for males, this one for females, we can see that there is a considerably higher percentage of males in the managerial and administrator category than females. In the professional category, there are more females, proportionally more females than males, and males again are overrepresented in the associate professional and technical group. We can start to looking down through this, and we can see there's some pretty profound gender differences. Men, about 25% of males are located in the craft and related. Only about 3% in personal services relative to 13% of females. So we can start to piece together some of the gender story on this basis. And again, looking at a formal test of independence, we have our results down here for the chi-squared, our p-value, and we have our figure for Kramer's to give us some sense of the size of the effect, or how strong is that relationship between gender and occupational status. So what I'm going to do now is I'm going to use another example, but we're going to look at households this time. So going back over here to our data and opening up our box, I'm just going to delete this by dragging it over into the bin. And you can do this simply by dragging and dropping on the icons to transfer them over. So to select for households, what we want is first of all to make sure the person number is equal to 1. We want the household reference person in that line. And then the second thing we want to do is to locate our household income variable and limit our results only to those households with an income above 0. So we've got our nat underscore distinct variable here, and we're going to define that as an income greater than 0. So when I apply this, the filter is now going to only include the household reference person and only include those households that have an income above 0. So don't forget to click apply pass-through filter. Filter is now applied, and we see that it's after graying out more. Again, there are less households and individuals in this data set, so we would expect to exclude more cases. And remember as well that unless you've saved your results, JASP is automatically going to update these tables. So now the table that we're looking at here is not entirely identical to the one that we had already. So we're going to what you can do if you want is you can close this down, you can export the results, you can save it, or you can start a new one. So again, it would make sense to give this a name, especially if you're saving your session, that you could give this the name perhaps individual, and you could give the second one the name perhaps household, just to keep track of them. So in this one, we're going to again replicate an example that we looked at a couple of weeks ago. You'll see here we've started up our new analysis window. It's empty because we've got no variables transferred over, and the previous one remains. Remember, what appears in this box is going to be affected by the settings that we have made up here in the filter. So just be aware of that. It's quite easy to go wrong there. So what I'm going to look at now is the relationship between economic hardship and tenure. We've looked at this one quite a lot. So our independent variable is going to be tenure, because we're suggesting, or we're hypothesizing, that economic stress depends on your household's tenure. In other words, we're saying that whether or not a household experiences economic distress is partly because of, or due to, whether that household is in the private rental sector, the social rental sector, and so on and so on. So our variable that identifies tenure is located about halfway down here in the list, and it says TENST. 1 is the short version, 2 is the long version. We're going to use the long version. So the independent variable is going to be set as the row variable, and we're going to look at, there are several measures we could use to look at economic hardship. There's this one that measures arrears of rent. There's also a variable called ends meet, which asks whether the respondent, the household reference person, believes that the household is able to make ends meet easily or not. So we're going to transfer this one over to the column, and we'll see we have automatically the table is snapped in there. Now we also want to add the same settings that we made before, which are to ask it to return some additional statistics in the third table down here, and also to return row percentages. So now looking down through the table, and we'll just snap it over again so we can see the whole thing. We can see that, so looking across the different categories, those who won outright, about 5% are in great difficulty. Those who won with a mortgage, 7%. But predominantly the highest percentages are here amongst renters and council renters, about 14 and 22% respectively. 14% of renters are experiencing great difficulty, and 22% of council renters are experiencing great difficulty. So again, while the majority of households are located over here in the sort of the sum to fairly range, the highest levels of great difficulty are to be found here amongst these groups. So that's starting to tell us something about the role of tenure. So the layer variable is also useful. What the layer variable is going to do is it's going to introduce, quite like it says, it's just going to split these results further by categories of whatever variable we decide to put in here. So what we might want to do is look at whether that differs by male or female headed households. If we transfer gender over into layer, you'll see that we now have 3 tables. This is the original table. This is no different to the table we just looked at. But we also have now a broken down table where we look at male headed households and female headed households. So we see here that it does seem to have some bearing on the differences. Now, for private renters, there's not a huge amount of difference, but for male headed households who are council renters, 16% report great difficulty, 23% difficulty. For female headed households, it's 25% and 22% respectively. So quite a substantial difference there. You'll notice also that we now have 3 different sets of test statistics and effect size. The effect size is the same regardless of the split, but what is going to change a little bit is the p-value, because again we're going to have differences between the observed and the expected frequencies. So, and again we can transfer these out any way we want, and the results will simply snap back to their original. So this is how to produce a contingency table. And again, remembering back to before, you can simply copy this table if you want. You can open up a Word document and you can simply paste the table. And if the table is quite long, what you might want to do is change the orientation of the page and paste it in. And again, remember to be careful about whether the source formatting is kept or merged. Generally merged is preferable, because then that will merge in with whatever defaults you have set up here for font and size and so on. And remember, you can also edit this any way you want. We might want to give a proper variable description. So ability to make ends meet. And this one down here, tenure. And you can also edit the labels. So you might want to make this a little bit shorter. And there's no real sort of rules about how you do this. If you're trying to make it fit into into a single page, then you might want to make these a little bit shorter. And again, you can mess with the column widths and so on by dragging these around. So that's just quickly how to produce a contingency table, how to return test statistics, and how to copy and paste tables from JASP.